Hi, my name is Michael Hall. I'm a neuroscience PhD student using a technique called magnetoencephalography to study epilepsy. So magnetoencephalography, otherwise known as MEG, essentially allows us to measure the magnetic fields in the brain to allow us to study things like language and vision. And we can also use this to try and find out what parts of the brain are responsible for generating epileptic seizures, and this is what my PhD is focused on. So the problem that we have with MEG is that we measure the signal produced by the brain outside of the head. So we have sensors like we see here on the image located outside of the head, and we want to find out where these signals are generated within the brain. So one potential technique that we can use to do this is something called beamforming. So beamforming sounds like some sort of a futuristic weapon that you might see on a Star Trek episode, but in fact it's a computer algorithm or computer program that we can apply to our data to be able to find out where signals of interest are located. And this was initially beamforming was designed in relation to the Second World War and in advancements of radar technology. And this was used in this context by using an array of antennas similar to what we see on the screen here, to be able to measure signal that's in the sky and detect signals of interest such as enemy aircraft. And the beamformer solution allows us to change the focus of these antennas so they zoom in or beamform on signals of interest and find their location. And it does this whilst being able to attenuate other signals that may be in the environment. So this concept can also be applied to MEG. So similar to antennas and signals contained within the sky, we have sensors or antennas around the head, and we want to find out where the signals are generated in the brain. So this has been used in MEG before, and there's an image here. So this is the kind of image we might be able to see when applying a beamformer to our data. And this hotspot here shows where we believe the epileptic focus to be contained. So my PhD research is looking at being able to optimize the current technology and to find out how effective it can be to locate areas of the brain that are responsible for creating epileptic seizures. And hopefully this will be able to feed into clinical practice, which is very useful for the pre-surgical evaluation of patients before going into surgery, whereby they may have to have part of their brain resected. If you want to find out more about my research and see some of my results, then please come see me at the LHS Postgraduate Research Day on the 2nd of July. Thank you very much.